You type def calculate total and freeze. Before you finish, GitHub Copilot already knows what comes next and what comes after that. It's not guessing forward. It's solving a Mad Libs puzzle, filling the blank using clues from both sides. 1 million developers trust it. It answers in under 300 milliseconds. Here's how. Here's the pain every developer knows. You spend 60 to 80% of coding time on mechanics, reading docs, checking function signatures, recalling syntax, not actual logic. Setting up a Flask route, writing a SQL join, reading a CSV. Same boilerplate over and over, stealing hours from real problem solving. This is why Copilot exploded. Over 1 million paid subscribers, 50,000 plus organizations including Google, Duolingo, Shopify. Developers accept roughly 30% of its suggestions, a third of shipped code Copilot wrote first. Microsoft reports 40% faster task completion. But speed like that isn't free. Here's the naive way to build this. Predict the next token using only code above the cursor. That's how early text models worked. But code isn't a sentence, it's structured. Editing inside a function, forward-only prediction guesses blind. It ignores everything below your cursor entirely. Imagine Mad Libs. You get a blank, the horde jumped over the fence. Read only the words before the blank, you might guess dog. Read the word after, over the fence, and you'd guess cat or horse instead. Code works the same way. The suffix matters as much as the prefix. Here's what nobody tells you. Copilot doesn't run GPT-4. It deliberately uses smaller 7 to 13 billion parameter models. Why cripple the smartest AI on purpose? Because a genius that answers in 4 seconds is useless mid-keystroke. Copilot trades raw intelligence for speed. 300 milliseconds beats brilliant. Remember the Mad Libs game? That's literally how Copilot is trained. Engineers call it fill in the middle, or FIM. The model sees a prefix and a suffix, and learns to predict the middle using clues from both sides. Codex, CodeLlama, StarCoder, every serious code model trains this way now. But Mad Libs clues aren't just the current sentence. Copilot also reads open tabs, imported files, file extensions, like flipping to other pages of the same story for more clues. A context selector scores relevance using BM25 keyword search and embeddings, packing the best snippets into a 4K, 8K token window. Here's the real engineering flex, fitting model inference, context selection, and a network round trip into 300 milliseconds. Miss that window, and developers stop looking at suggestions entirely. Speed isn't a nice-to-have here, it's the entire product. One trick makes this possible: speculative decoding. A tiny draft model guesses several tokens fast. The large model verifies them all in parallel, instead of generating one token at a time. Like a fast reader skimming ahead while an editor checks the work. Result: 2-3 faster responses. Speed also means geography. Microsoft runs inference on Azure GPUs across multiple regions, routing you to the nearest one. That single decision shaves critical milliseconds off the round trip. The difference between ghost text feeling instant or feeling stuck. On screen, this becomes ghost text, grayed out code appearing in line. But Copilot doesn't fire a request on every keystroke. It waits 300 to 500 milliseconds of silence first, debouncing, so it isn't flooding servers while you're still mid-thought. There's another trick: prefetching. The moment you accept a suggestion, Copilot immediately starts generating the next one, before you've typed the next character. It's betting on your next move, like a chess engine calculating ahead while you're still deciding. Put it together, and here's the journey. You pause typing, the extension grabs context, a heuristic scores relevance, the prompt gets built, it routes to the nearest region, speculative decoding generates tokens, and they stream back as ghost text, all under 300 milliseconds. Now the part that compounds. Every accept and reject gets logged. Code context, suggestion, outcome. With 30% acceptance across millions of developers, GitHub captures millions of labeled examples daily. That data becomes fuel for the next model version. Back to Mad Libs. Imagine after every guess, someone tells you instantly whether you were right. Over millions of rounds, you'd get scary good. That's Copilot's feedback loop. It doesn't just play the game, it gets graded on every single round, forever. At scale, GitHub runs thousands of inference requests per second across Azure GPU clusters. It load balances by queue depth, not round robin. Copilot Enterprise gets priority queuing, a lower latency SLA. Overnight, GPU pods auto-scale down as time zones go quiet. Copilot isn't alone. Amazon's CodeWhisperer took a different path, filtering training data to avoid restrictive open-source licenses, adding a code reference tracker that flags verbatim matches. Why? Early Copilot versions occasionally reproduced copyrighted code exactly, sparking real lawsuits. Then there's Tabnine, running smaller 2 to 7 billion parameter models fully on-premise. No code leaves the building. For banks, hospitals, and governments who can't send proprietary code to an external API, that trade-off, lower quality for total privacy, is non-negotiable. This stack didn't appear overnight. 2021 Codex launches, fine-tuned GPT-3 on 159 gigs of code. 2022 Copilot goes public. 2023 GitHub ditches Codex for custom models trained on trillions of tokens across 80-plus languages. Each jump, faster, cheaper, smarter. In your next interview, drop this. A 30% acceptance rate sounds low, but it's not a weakness. It's the training signal. Every rejected suggestion is still useful data. Copilot isn't just autocomplete. It's a distributed labeling machine disguised as a coding tool. But it's not magic. Feed Copilot a messy file with no imports, vague names, and its guesses degrade fast. Garbage context in, garbage suggestion out. The model is only as good as the clues you give it. Clean code is literally training data for your own autocomplete. Want better suggestions right now? Keep related files open in tabs. Copilot reads them. Name functions descriptively before writing the body. Add a comment describing intent. These aren't just good habits, they're literally feeding the context window. Copilot's model depends on. Zoom out and the numbers are wild. 40 to 55% faster task completion, over 1 million paid developers, 80-plus languages supported, all running under a 300 millisecond latency ceiling. This isn't a party trick. It's core infrastructure for how software gets written. The way I'd explain this to a PM, Copilot doesn't just predict what comes next. It predicts what belongs in the middle, using code before and after your cursor. That training shift, fill in the middle, is why suggestions feel like mind reading instead of guessing. Here's the entire system in one picture. Your editor extracts context, a selector scores relevance, a prompt gets built, speculative decoding generates tokens across regional GPU clusters, and it streams back as ghost text, while telemetry quietly logs the outcome for tomorrow's model. Here's a detail most tutorials skip entirely. GitHub batches requests. Instead of one GPU inference per developer, it groups multiple requests into a single batch call, cutting per request GPU overhead dramatically. The same trick rideshares use, pooling riders headed the same direction. This is the pattern behind every fast AI product now, not just Copilot. Smaller distilled models, aggressive caching, regional routing, speculative decoding, continuous feedback loops. Learn this stack once, and you can explain how any real-time AI system actually stays fast at scale. So next time ghost text appears in under 300 milliseconds, remember, it's not just autocomplete. It's a trillion-token model playing Mad Libs with your entire code base, verified twice, streamed instantly, graded on every guess you make. That's the whole trick. Copilot plays Mad Libs with your code, using clues from before and after your cursor, verified by a second model, streamed in under 300 milliseconds. In your next interview, explain FIM this way and sound like you've built it. Subscribe for the next breakdown.